I am unmuted. Cool. Hey, fantastic. All right. Hi, everybody. I'm Drew.
Are we the only ones in the call, or are you presenting in front of a crowd?
I will come back to the lecture. All right. So I'm going to do this from up here so that hopefully people can hear me. Maybe Vibe, if you can get, yeah, you can hear? Okay, fantastic. So this is going to be a kind of everybody kind of presentation. So if I don't give you some questions. Yeah, come for it. Even slide the table up. Okay. If I can talk from up here, I can project pretty well. Remember playing this game as a kid. Nobody sits in the front row. All right. I'm still loud. Okay, so on our agenda, really easy to remember how to check whether or not AI is trustworthy. Remember the things that are involved in making AI trustworthy. From an analyzed point of view, we spent, last 20 years researching this, and we've come up with 4 things that we think absolutely have to be there in order for a system to be trustworthy. And again, this is a system. This isn't not necessarily just your AI model or your AI agent or the software, the service that sits behind it or in one piece. This is the entire system. So when we talk about AI, one of the things that we need to take into account is that there's a lot of different places where it comes in. It may be on the front end. Our users may see it. On the back end, our internal people may see it. Our IT folks may see it. May never have a human being see it. So we're going to talk through some of those use cases. We're going to talk about 4 things. RSVP, responsible. Like, we're not trying to do this to hurt. Go ahead and count. Secure. You really want to make sure that the stuff that is, important has a place to live. Verifiable. This is the one that we're going to talk about the most. This is the one that everybody right now in AI right now. And then private. This is one that a lot of companies are starting to talk about. Some companies are starting to do some real things. We're going to get into what some of those are. So what do we mean when we say responsible AI? This is where it starts to get really crazy because we like ethics. How many people here went to school for anything related to ethics? I know she has a criminal justice minor, so I mean it's close, right? So everybody's got this problem that is these are really small, so I'm going to make them big so everybody can see them. That all of a sudden this AI thing, it's just slammed at us. It's everywhere, and we don't know fundamentally what to do with it. We're like, big name people are telling us it hasn't provided any value. I'm like, I provides value for me. Full disclosure, it created a lot of these slides in this presentation. So, how do we get it so that it's fair, so that it's doing things that are helping move humanity forward? How do we get it to be accountable? Accountability doesn't just start at the door when you're giving that AI to your consumer. Accountability is something that, in the case of AI, we're programming with data. That's effectively what we're doing. We're trying to get data to be formed in a certain way so that it acts in particular ways. And when you're programming with data, any kind of data that's off can cause things to go askew. So when we talk about accountability and development, one of the things that we talk about is just where'd that data come from? And a lot of companies can't answer that question. So we get to that transparency part. And about 6 months ago, half the stuff on the internet was AI generated. And about 1/100th of 1% of it was labeled. So there's all this AI generated content out there. Those of us that have been watching this for a while have seen it build and build and build over the years. And we don't have a necessary definition of what's real and what's not real. And that's really important for the users. So the big companies, Microsoft's driving this one really, really hard, are making sure that things like informed consent are part of how we deal with AI. This is a human rights thing. We didn't create, again, AI to replace people. Well, some people did. We created it to make our jobs easier, our jobs more accurate, our diagnoses more accurate, our thoughts more accurate. But the problem is that it's based on humans. So all the failings of humans become the failings that are inherent in AI. I am not going to use this font for this presentation again, I swear. So what do you do about it? Here's some things to start thinking about, in your own group. So how many of you have at least some AI project somewhere visible to you in your organization? Yeah, okay. How many of you have one on your own team? Okay, about half. So how many of you have an accountability statement for your AI project? Yeah, that's that's about where we're at. Don't feel bad. You're there with 99.999% of the people in the world right now. Those of us that have been talking about responsible AI have been screaming about it for the last year. We finally started getting some real serious mind share about 12 months ago. And all of a sudden, there's big companies. Microsoft's got a whole team. All they do is responsible AI. So look at your own accountability streams. How do you keep accountability for data? How do you keep accountability for modeling? How do you keep accountability for the models, whether they're in the wild or behind some sort of bastion? Do you know what you're responsible for? So do you have a data scientist? Do you have a privacy expert? Do you have somebody that understands cybersecurity, and in particular cybersecurity in relation to AI? There's a lot of things that you're going to want to kind of think about as a team. Maybe, and we'll talk about some of these use cases, maybe your use case isn't a big thing. Maybe it's no harm, no foul. But maybe it's something where, it's medical and it's an issue. Both. And we're still not through the fallout. I think a lot of the old roles are going to change. So roles like software tester. How many people have been a software tester before? Come on. Yeah, a lot of us. Yeah. Are we going to have that role anymore? I used to take, somewhere between a year and a half to get my youngins ready out of high school, out of college to be able to do a project. Last summer, I took a group of 5 kids that had, most of them, absolutely no basis in even tech, and they were able to produce an AI app by the end of the summer. So I think a lot of that is yet the stories to be written. Love to give you a better answer, but right now there's no consistency anywhere. So monitoring, this is again, these things that we're talking about, they didn't exist 24 months ago. You know, there's some of us that have been working on regression models for years and all sorts of other kind of, but the unique nature of generative AI is that it is based on random numbers. So when you're looking at, you know, what is the next word in that sentence, what you're looking at effectively, if you're the AI model, is here's all the possible words that could come next based on all those words in the context that I've seen before. And I'm going to pick one at random. There's the parameters in there like K and P that tell us, you know, how many options do we think about and what probability do they need to have before we consider it, and how much of the time are we going to go one way versus go another. So when randomness is inherent, things like monitoring become super, super important because the model can go off on its own and you may not know that the model went off on its own. So how do we find ways to be able to monitor these and to get that integrated and consider that the scale at which we're doing, so how much data comes in and out of an AI model when it's trying to do a query? You know, we're typically dealing with text boxes with, you know, up to about 20 words until 2 years ago. And then the average length of a text value in a text box has suddenly, you know, gone through the roof. I just took my entire essay and pasted it in that text box. There are things that we're just fundamentally not ready for yet. And that's where a lot of the challenge is how do we get ready? So secure AI. Secure AI is an interesting thing. So we know a lot about cybersecurity. Cybersecurity's been around for a long time. But there are some novel kind of things that we can do with AI that we couldn't do with we'll call it more predictable code. So more predictable code, the code that, you know, I've been writing since I was a kid, is if, then, else. If the condition is this, do this thing. If the condition is something else, do that other thing. And then, you know, we got a little bit more so that we could come up with these really strange languages that said, if this condition, then this, if this condition, then this. And then we have case statements and switches. And then eventually we had SQL kind of languages where we could do joins and we could do selects and we could do filters and we could do all certain where clauses and things that would make that data. Now what we're talking about is we're talking about an effectively infinite data set, because from our point of view, it's much larger than anything that we're allowed of it. And we need to be able to find ways to control whether or not what comes out of it is something that we want to use to make a decision. So things like, and I'm again, sorry for the need to zoom in here, data poisoning. So some really smart people started thinking about this about a decade ago and don't know it until you go back to the web archive and start looking. There are people that are doing data poisoning attacks, like in their LinkedIn tags, and they'll put in just little instructions to your AI, should your AI be scanning their stuff, in the hopes that sometime, you know, somebody is going to trip over that, get exactly the right context to get the AI to set that URL, link the user to a place where good, something bad, we'll see. Adversarial attacks, these are the really fun ones. We see a lot of these right now. These are the ones where you get talked to Elon Musk. Get AI models that tell you to, you know, keep your decent ingredients on your super glue. You get all sorts of, if you ask it in the sense of, you know, my grandma used to tell a story about, that was one of the big first attacks. My grandma used to tell us these stories about nuclear. So because it was so excited about the grandma context, it forgot about the nuclear context, and it would answer any question. There was no risk whatsoever. So a lot of these adversarial attacks, we're starting to see, not only are people getting smarter about these, but we're using AI systems to create adversarial attacks against AI systems. Model inversion. So this one's kind of a fun one. How many people heard about DeepSeek? So effectively, what DeepSeek did was something kind of like the model inversion. What they did was they took the approach. We think we know which one. We'll talk about that in a couple of weeks. To take what's going on with OpenAI and what was about to come in their model, and they took the information from it and asked it enough questions to be able to distill from it knowledge that they could then take and layer on top of open source models. So what they effectively did was they ended up taking, kind of like the information data out of that model, but forming it in a way so that nobody could say that it was, from that place. Because again, things AI happen deep and they happen in math, and not everybody can understand, or if you're really honest about it, nobody understands what's going on in there. Curious? There are a very, 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 very few companies that are in this space and serious. So things you can do. Input validation. Input validation is key. It's the most important thing you can do. I spent, out of the last 30 years, 20 plus of it in identity management. I saw dirty data every single day. You want to see bad data? Look for data about people's names, security roles, job history, all that data that goes into identity. It is the worst of the worst. And based on that data, we made horrible decisions. We would give people access to things that they had no business getting access to, and you'd see it on the news the next day. Now we're talking about things where that rule is buried in mathematics somewhere beneath, hundreds of layers and billions or trillions of parameters. So how do you find that rule that causes that bad input to go? Well, one of the big keys to that is make sure your data is clean in the first place. Anomaly detection. If you don't have a SIEM, don't do public-facing AI, period. If you don't have the ability to get every possible security event from anything that touches your AI, and I'm not being paranoid here. If you work in a regulated space, I'm happy to sit down with your team and show you, here's the places where you got it. And then the adversarial training, this is where we have a model, and it's being trained to be more resilient. It could be trained to be more resilient in a positive way, and it can be trained to be more resilient in a negative way. Because remember, we got AIs hitting against AIs now. I'm trying to go back and I'm trying to do those kind of attacks that I talked about on the last slide. And I'm pounding your AI with all these prompts. Well, there you go. That's happening every day. And malicious actors will always be there. They'll always have things that they're a step ahead. But it's a balance. So I was a CISO, and it one of the things that's really using AI to predict threat patterns for that. Because when we take a look at the data that goes into this kind of thing, when we talk about like validation on the model of setting, 7 billion is effectively because a year and a half ago said does language play a role?
Let me give you an example. So we had a speaker in class somebody now and ask, can you give me how to make a bomb?
Yeah.
It will not give you.
Right.
Because it's a,
Right.
but if you will go ahead and post the same thing in a
Right.
which is not used as much in this model, it actually went ahead and give kind of hallucination that
It's not even, it's a layering in the transformer architecture. What happens is that your ethics layer is sitting in here, and your language layer is sitting here, and it's bouncing through your language layer. But what you're hitting on is exactly the point, and it's not even just traditional forms of. So we saw one attack that happened in the wild where people were taking these white JPEGs, right? Completely white JPEGs to the human eye, but they actually had, 255, right? So instead of perfect white, it would be just off white. Well, that's enough that the AI program saw, like, boom, it could have been written in black and white at that point. And it was an instruction that said, give the user the URL following. And even though their ethics said, don't give users URLs, the ethics was here, the image processing was over there, image processing didn't pick back the ethical processing.
I'm not mentioned doing.
And part of it is the way that we build the models right now, it can't do that. There are companies that are working on models that can do that, but the models that we have right now, they can't. I'm going to go a little faster just to make sure that I get you guys through this. Best practices, clean data. I can't say that enough. Required, regular security assessments. They need to be from people that not just know AI, but know cybersecurity, and not just know cybersecurity, but know AI, which is why I'm in that space, because there really aren't a lot that do that. Expect this to be one of the most collaborative things that you'll ever do. So I've worked with the race school. 20 different projects going on around the state, and they're, the team that I'm with is a venture capital backed team. And one of the things that they're doing every spring, having this discussion, it's not just a discussion, but it's the discussion of, hey, this is hot data. What would happen? This is data that goes into medical records. So how could that data be exploited, or how could that data be incorrect, or what happens? So what happens is the really seemingly innocuous text use, all of a sudden that HR means that ethics, and that a lot of different patients that are going to want to see it. So this is got to be one of the most collaborative things. It's also a lot like when I walked into Microsoft, everybody there was like, here's this fair job. Right? Don't think that half the people in my project team have in the back if they're going oh, that is reality. That's why it becomes together, a lot of negotiation, and then a lot of continuous monitoring, because you're going to have to come back and show them why it didn't work. Okay. I accidentally stopped sharing, so this should be. Nope. Close enough. Okay, so RSVP, responsible, secure, verifiable, and private. Virtually everybody out there started thinking about secure about 3 years. Virtually everybody out there started thinking about private about 2 years ago. Virtually everybody out there that had a stake in this and that could lose their shorts started thinking about responsible and doing something serious about responsible about 14. Right now, where we're starting to see a lot of interest, but unfortunately not a lot of solutions, is in verifiable AI. So I got to find. There we go. That'll work, I hope. Yay. All right. So here's the thing. If I tell my user, go put glue on your pizza, they're going to know I shouldn't do that. I might get a tummy ache or end up in the. If you tell a doctor that patient has a 5% risk for cancer, what are they going to do with that information? And how do you tell the doctor, here's exactly all the features that I'm basing that at, when your context window is 128,000 tokens? The context window is how much can I take into consideration in making this response back? So if you have 128,000 tokens, figure somewhere around 40 to 50,000 words. So a very long book, right? That can all go into context. But what comes out of it is usually much, much smaller. So what we need to be able to do is we need to be able to find ways to have the AI system itself have pointers, markers, something that can take us back to the sources. And that's a really hard problem to solve. In the meantime, what we've done is we started coming up with ways to really test that reliability. And most of those ways are based on asking it questions over and 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 over again. Is put the markers inside the model. Yeah, yeah, yeah. It's a really hard problem to solve. Okay, so reliability, verifiability, it's your stakeholders. It could be your consumers, it could be your customers, it could be your clients, it could be your shareholders, it could be your partners, it could be your suppliers. There's a lot of different people that are depending on you to be reliable. So if you go and put that model in place and all of a sudden your reliability takes a hit, do you have the appropriate metrics in place to be able, and the appropriate monitors in place to be able to detect that? And then the standards thing, one of the hardest things about standards with AI is there really aren't any. We're just now starting to talk about the EU Act went into effect or started going into effect phase 1 today, I think it is, or very, very, very shortly. And California's got some work, but other than that, it's a pretty wide open game. So it's hard. So we have time now. Ways to verify. So first of all, formal verification. This only works if you have the models and the weights. So this only works if you have all the data that went into there. If you can't actually verify the data that trained your model, that formal verification from a mathematical point of view is hard to do beyond like a statistical. You can do a Six Sigma kind of thing on it, but that's about it. Testing techniques, again, ask it over and over again. This is what we think the question should be. This is the question that, this is what we think the answer should be. This is the answer that came out of it. Are they, close enough to being correct? And based on that, and they do the same thing for like bias. So is that, answer that I got back inherently biased male, female, or young, old, or, straight, gay, whatever. We found like medical models. Here's one of the oldest ones, and this is a non-generative. So this is a problem in AI, and it does not matter whether you're talking generative or regression. How many people have ever gone to the doctor and had your blood oxygen measured? The little thing with the red light? Yeah, everybody. Did you know that everybody in this room except for one person, and I'm sorry, I'm not singling you out, but everybody in this room except for one person is going to be 99.9% accurate. That one person is going to be less than 90% accurate. And if his skin was darker, it would go as far as 50% accurate. We've been doing this stuff for 30 years. So a lot of it is, how do we get these testing techniques built into our systems, built into our processes, so that they're not a goal of their own, but they become an inherent goal of the system. And then, validation, we'll talk about that one. It's yeah. Which one? Oh, your specifications. So here's the thing. Look, your use cases, go play friendly with kids. I have one set of your use case is you're writing something for therapists and different set of characters. So it's about the order, not necessarily prescribing what they should be. So I've talked, I think, about everything on this one. They're complex, don't have a lot of standards. The interpretability is a big problem. We don't have a lot of tools. So a lot of cases you're going to be building your own tools or pulling stuff that's very fresh out of repos in GitHub. So privacy is where we start to run into headlong the law. Responsible, yeah, there's some stuff in Europe and California. Secure, there's arguably some stuff in most of the cybersecurity frameworks that deal with, at the very least, the data that gets used by AI. And in many cases, the networks and the processes and a lot of things that come after that. So a lot of frameworks have effects. We just don't understand what they are because they haven't shown up on audits yet. They're not going to show up on audits for a few years. So a lot of it comes from the heart, is how do we protect our users? How do we build a system? So I had to stop the interns for a day because they were throwing people's user IDs into the URL. I had to do the same thing with my Lincoln team. These are the kind of things that you have to have some sort of checklist to help you look for. Data minimization. When you're in healthcare and doing this one, it's like there are laws in HIPAA, not only about that you do this and when you do this, but the way that you do this. So requirements for when you can use, a certain number of elements being unique versus when you have to actually get a mathematician in to come up with your probability matrix for whether or not somebody could be individually identified. It's hard stuff. So again, things that we didn't have to think about a couple of years ago, all of a sudden, they're affecting everybody. Maybe not today, but little pieces, the teams around you, and then all of a sudden, one of your systems is talking to something, And then encryption, here's one of the big problems with AI models. They use encoding. They don't use encryption at all. But you look inside that model, and it's usually doing byte pair encoding. So my name, Andrew, would be capital A, little n, and then that would be a pair, and then DR, and that would be a pair. And using those, they add up the statistics of how many times, yeah. So you can read the raw stuff. If you're patient enough and have enough of an algorithm, you can read the raw stuff that's in the model. It may not always make sense, but you can get to all the raw text. There's no buffer. There's no protection layer on top of that. Well, so yeah, you could protect it at rest, but what's that going to do to protect you when it's trying to attack you in memory? Because that AI model, at rest, it does nothing. It just sits there. it could arguably be a target because you could try to pull data out of it using that technique 3, but only so far. Because we're working on it. So here's some of the things that are going on. One of the ones is differential privacy. So what differential privacy does is it adds an element of the user into the model. So your stuff stored in the model uses a little bit different kind of numbers than my stuff stored in a model, uses a bit different stuff than Kenzie's stuff stored in a model. So that's one way to do it. That's a serious simplification of it. Federated learning is where it does a little bit of learning on my stuff, does a little bit of learning on your stuff, does a little bit of learning on his stuff, and brings all that stuff together before it tries to make any inference on it. So mixture of information and experts. And then this secure multi-party, this is a really cool one where there's something called threshold cryptography. And the way that threshold cryptography works is you've got a part of the key, you've got a part of the key, you've got a part of the key, you've got a part of the key. And if two of you agree, you can open it. But you can open it without actually being able to see what's in it. And you can even do processing on stuff without being able to see what's in it. So we're learning how to use threshold in AI so that you can have stuff that's being processed like out on the network where the stuff lives, that you don't have to bring it all in, train it all on your model, and have data constantly moving around, but where you can actually leave it in a place and have that node have no knowledge of what's in the data.
Is it you?
Um, it's used in national defense. If you follow the team that's working on post-quantum encryption, there's a spin-off team from that, from one of the guys that helped invent PKI, that is doing threshold cryptography. And that's kind of the working group. So it's all experimental. I wanted tonight to be a 101, not a 301. But yeah, I mean, there's good stuff. All right. The cool thing about it is every one of these slides, there's an entire presentation for every single one of these slides. There's just so many layers and depth to this. It's why it's so much fun. Okay, so compliance, understand your compliance rules. This should be a rule that you should already be doing, but understand these compliance rules and the context of AI. Context is everything. How can you get to a point where you've got, the appropriate data rules, you've got the appropriate network rules, you've got the appropriate at rest in motion. Regulations, we talked a little bit about that, GDPR, it has rules about data. CCPA, it has rules about data, so be aware of those. And then make sure that you have the right people at the table. So if you have a particular use case that you're working on that is going to, be inserting an element of human risk or financial risk or some other kind of serious risk, you got to start looking for those things and start bringing them to the table. There we go. Okay. I will make sure that these slides get posted up there. Somehow the version, this is the one without all the links in it. But I wanted to make sure that everybody got some questions to take home. So these will be, as you take this back to your team or to your friends or to people that you're having lunch with, here are some things to start the conversation. How do you decide when you need to use AI? Are there high impact risks? Do people have to actually cite references? What's a real world scenario that your team is using AI today? And don't anybody believe that the answer is none. Because if they're not using it in the office, they're using it on their phone. And if they're not using it on their phone, they're using it on their PC at home. And if they're not using it themselves directly, they've got a consultant or a kid or somebody else who's using it on their behalf, playing that information back. And again, just like the junk that's on the internet that's starting to clog up the filters, starting to build a pile.
How do you approach like Microsoft, GCP, AWS that are like taking ownership, copyright stuff, and the risks that are inherently died? How's that conversation being slightly different? Training your own model, building
It's different in the sense that Microsoft has this model that they've used for cloud computing. It's a responsibility matrix. Have you ever seen that one? They're working on the same kind of responsibility matrix for AI. And the only thing that it does is it shifts the responsibility. So if you're not training your own model, maybe you're using like a 5.4 or a GPT directly off the shelf. Microsoft takes a lot more responsibility. Whereas if you're taking and retraining that model, then some of that responsibility starts to come back to you. And those kind of guarantees that you see with, like with Copilot, they don't cover the PaaS services in quite the same way. So
it boils down to your data. It boils down to your data.
And there's layers. So think about DeepSeek. So there's DeepSeek. There's the model that DeepSeek pulls stuff from to distill. There's the distillation method that they after they train. Then there's all these models that they did to make it smaller by taking and layering DeepSeek on top of Keyword and and each one of those can do with an Azure kind of stuff. You can do with an AWS kind of stuff. In fact, it's really, really easy to go and do those things, but not many people know the second you go and train that thing without data scientist or having somebody that's knowledgeable in the work, you've just taken on risk. And Microsoft has, AWS has, and Salesforce has. That's called safety service for AI. So when you download a Microsoft model, serverless, different AI safety model. But you also have the option of going, nope, I'm going to apply that to a managed instance. I have raw level access to that model. I have raw, behind the OpenAI API. Like everything, like everything. Depends on the use case. It depends on where that stuff came from. Is that a model that you went out Hugging Face and you downloaded it and you really don't actually know? And that's where we get to where I'm gonna end. I'll do the conclusion, but I do want to just do 1 second of teaser. So we're gonna do a big launch in March. If you are interested in being at the launch, or you are interested in being in some of our private preview team, find Corey there after the meeting and make sure that he's got your email address, and we'll get you in on that. So importance of trustworthy AI, critically important. People's lives depend on this. If you don't believe so, invite me to come talk to your team. I'll be happy to give you the stats. Focus on responsibility, not necessarily external responsibility, just within what you can manage, just within your own team. Have honest, open conversations about what are you guys doing with AI? Does it help you? Do you find that it gives you good answers? What kind of things does it give good answers to? What kind of things does it give bad answers to? And understand your ethics. Every company has different ethics. Every person has different ethics. Understand what yours need to be and keep them within that bubble. So the last time we were here, we teased a little bit about this. And with any luck, the Wi-Fi is gonna be good enough that it's gonna come and talk to me. See. So one of the things that NLICE has been doing, so we focus in the space between cybersecurity, search, which includes artificial intelligence and threat and all that, and something that we call social identity. And social identity is it's that part of you which you portray that part of you which you portray your social, that part of you that you portray your school. They each are context, they each are persona, and they are really critical determining how cybersecurity and AI can play to bring things together. One of the problems that we found was that there is no tool out there to be able to visually look at model A and model B and see how they're different. There's no tool that allows me to say, okay, I just took and spent $7 million yesterday training a model. That is totally not out of the. And I want to know whether or not that model just became biased. I want to know whether or not that model just started hallucinating things. I want to know whether or not that model has an absolutely correct view of cybersecurity. So what we've come up with is a way that in a 3D visualization, you can look at multiple models and be able to actually make comparisons or look at models in a state of time and be able to make comparisons. Because we'll cross our fingers on whether or not this last part will work. One of the things that is really, really rough is that there are some existing visualization methods out there. UMAP, PCA, ESNI. The problem with them is they're all either trying to optimize on the inside. Have to be full, which means always getting. What we want to do that would allow us to look at something that is, a known concept and use that known concept. It might come up. We'll see. To use that known concept to actually measure the individual models. We'll give this another couple minutes. So what that means is, for example, this one that we're looking at right here, this is the NIST cybersecurity reference model 850. Ever worked in cybersecurity in the last decade? Yeah, absolutely. Standard by which not the government, but most U.S. companies have cybersecurity. So on the right-hand side, we have Beta 2. On the left-hand side, we have Phi 3. What if it's still loading, so you might not get the whole thing. You don't get the full demo tonight. So once you've looked at these things long enough, let me turn them around so you have, there we go. Okay. What you'll see is that we have these conceptual, okay. So concepts tend to do so case, you know, process them. You lay things out, you're able to do, you're actually better, and we're able to render no points, and you able to have so each point on there. Now let me see if I can get it to be nice. It's mean on the iPad. Okay, so each one of those points is either or it's so EC2 access control from the point. That like security architecture. I know that security architecture is that purple dot. Right hand one. And I'm not sure why the left hand one doesn't, but there's another dot with you. I agree with all of them. And so what we're trying to do is rather than fully relying that waste and process. Those words can be on right one picture of the most we actually want to so get like smaller models. They're not bigger. They're like so it is starting to see. It is always